Welcome back, guys. Today we will start with sorting. First, we'll see what sorting is. Arranging elements in particular order is called sorting. Usually, we do it in ascending order. There are usually five types of sorting. There are also more complex ones, but first we'll see these five types: bubble sort, selection sort, insertion sort, merge sort, and quick sort. In this video, we will see first three types. Now, let's start with bubble sort. In bubble sort, what we do is we compare adjacent element and swap it if needed. For example, if this is our array 5 to 8 1 3, we swap adjacent elements like here 5 and 2. And as 5 is greater than 2, we need a swap here because we are sorting it ascending wise. So we will swap it. Then between 5 and 8, there is no swap needed. So we'll keep it as it is. 8 and 1 swap needed. So we'll swap it. 8 and 3 swap is needed, so we'll swap it. So in pass 1 we get highest element to the last. Similarly in pass 2 we get second highest to the second last position, third highest to the third last position in pass 3, and fourth highest to the fourth last position in pass 4. And at the last pass we get a completely sorted array. So in this algorithm we require n minus 1 passes. Now we will see the implementation of the code. First, I'll just write the code and explain it to you. Here, we have taken data type as void because this function is not returning anything. And we have passed array by reference because whatever changes are made to the array, we need that to be permanent. Now we have taken a boolean variable called swap and set it to false. What this will do is it will help us to check if the array is sorted or not. Now we have started the first loop. This first loop will be our number of passes, and we have to run n minus 1 passes. That is the reason we are taking it till size minus 1. Now, for every pass, we have to change the swap variable to false because we have to check at every pass that if the swap has happened or not. Now, in the inner loop, we will run the loop till from j equals to 0 till j equals to size minus I minus 1, because here you can see once at pass 1 we got 8, that is the highest element at the last position. Second pass we will run till I equals to 4 only. That is the reason we are taking it size minus I minus 1. Now once we start the inner pass, we'll just check if the current variable is greater than the next variable. And if it is greater, then we need a swap. And after every swap, we will just change the swap variable to true. So, um, like that, we can know if the array is sorted or not. Here, if the swap variable is false, then we will exit the function, because if the swap variable is false, it means that the array is already sorted. As you can see, in this array there are no swap needed, so it will indicate that array is already sorted and we can return before completing all the passes. Now first I will show you just the basic output, that is our raw array. Here you can see this is our original array 8 5 7 10 2 3, that is unsorted array. Now we'll just apply the bubble sort function, and you can see the array has been sorted completely. Now coming to selection sort. In selection sort, we select the minimum element and place it at the beginning. For example, what we'll do, we have a array 5 2 8 1 3. Now what we'll do, in the first pass, we'll find the shortest element, that is 1, and we'll place it at the beginning. Now, for the second pass, we'll consider our array from second position. Means the first element will not be considered in second pass. In second pass, only four elements are there. Now, in four elements, we will just check which is the minimum, that is 2, and we'll put it in the beginning. Similarly, in third pass, there will be only three elements, and in this, 3 is the minimum, so we'll just put it at the beginning, and so on. At the final pass, we will get the sorted array. Now, let's implement selection sort. Again, we are taking data type as void because this function will also not return anything, and parameters will be same as the previous function. Now, we'll start the function. In this, we have to find the minimum element index. So first we will take the min index variable. Now, once we start the loop, we will run the loop till size minus 1 because you already know that we need n minus 1 passes. Now, what we'll do, we'll put the minimum index as the current element, that is I, and then we will start the inner loop. Here we are taking j equals to I plus 1 because, as I already said, we are not considering the elements that are already sorted. We are always taking the array from the next positions. So we will just check that if the current element is lesser than our minimum element, and if yes, then we will just update the index. Now, after this pass, we'll get the minimum elements index. And what we have to do is we have to swap the minimum element with the beginning element. So first we'll also check that if the beginning element is lesser than or greater than the minimum element. So we'll just check if minimum element is lesser than current element, and if yes, then we will just swap them. That is it. This is the implementation of selection sort. Now I'll just comment the bubble sort function, and again I'll show you the output first. Here you can see we have unsorted array, and once we apply the selection sort, the array should get sorted. Yeah, the array is sorted. This was the implementation of selection sort. Now, the last topic, insertion sort. In insertion sort, we assume that first element of the array is a different part of array. Basically, we divide array in two parts, first element and rest of the elements. So, as first element is a single element, it can be considered as sorted part of the array. Here you can see, and all the remaining elements will considered as unsorted part of the array. Now, what we'll do, we'll pick every element from unsorted part and we'll just put it at the correct position in sorted part. So here you can see we pick 2 from the unsorted part and we will put 2 to the left of 5 because it is lesser than 5. Similarly, in next pass, we will take 8 and we will put it at the correct position in sorted part. Then 1 and then 3. And after the final pass, we will get a completely sorted array. Now we will implement insertion sort. Same data type because this function will also not return anything. Also same parameters as well. Now starting the function, in this we will start the inner loop from 1 because we are considering first element as sorted part of the array. So we are starting with 1, that is unsorted part of the array, and we will run till the last element. Now what we will do, we will take the first element of unsorted part as key. First element of unsorted part we have taken as key. Now what we will do, we will take j as I minus 1, that is the previous index. Now j is last element of the sorted array. For example, take a random pass. Let's say we have taken this pass. So this is our key, that is first element of the unsorted part, and we have taken j as last element of the sorted part here. Now what we will do, we will reduce the index j till we get the element lesser than our key, which means first we will check if 1 is greater than 8. As 1 is not greater than 8, we have to put 1 on the left side, so we will decrease j. Then we will check 1 is greater than 5, no, so we will again decrease j. Then we will check 1 is greater than 2, no, then we will again decrease j, and we have to decrease j till j is greater than equal to 0, because if j goes to the negative, then it will create an out of bound error. So we'll just apply while loop till j is greater than equal to 0 and array of j is greater than key. Now what this will do, it will give us the index where we have to put our key. Basically it will give us the correct position of key. What we have to do, we have to just shift the, which basically now 1 is not greater than 8, so we have to shift it to the right, because somewhere to the left we have to put 1, so we have to create a position, and for creating that position we have to shift it to the right side. So here we will shift all the elements to right. Now after sorting shifting all the elements, we will just put the key at the correct position. That's it. This is the implementation of insertion sort. I will just run it once. First, we will comment the selection sort. Here you can see this is an unsorted array. Now we will apply insertion sort. Here you can see the array is sorted. Now, the time complexity for bubble sort is O of n square, and for rest of the sort is also the time complexity is O of n square. Now, these three sorts are used for learning, but they are not considered for real world uses. In real world, we usually use merge and quick sorts, which we'll see in next video. Thank you.